Hello, in this video we're going to discuss implementing fan control in Linux. If you enjoy this video or if you learn anything in this video, please hit the like button. First, to give a little background on this, a lot of motherboards have fan control implemented in the BIOS, and some motherboards, especially newer ASUS motherboards, some of the newer MSI motherboards, do actually do a pretty good job with fan control. But some of the motherboards don't necessarily do a good job with fan control in the BIOS, and some of the older motherboards don't. For example, my motherboard is probably 10 or 12 years old. It has fan control, but even when I set it to the silent settings, it's not completely silent. And I have a tower air cooler on my processor, and the fans just do not need to be running as fast as they are most of the time. With fan control, basically what's supposed to happen is when your CPU starts to warm up, then it increases the fan speeds. And right now, with my BIOS settings, the fans are running at too high of a speed for what I need. Even at idle, the system case fans are running over 1,000 RPM, and in reality, they probably can be running at maybe 600 RPM and still keep the CPU really cool. The only time my CPU is ever really stressed is if I'm doing something maybe in FreeCAD or Kdenlive, and at that time, when I'm really stressing the processor, that's when I want the fans to ramp up in speed. But if I'm just doing word processing or web browsing or something like that, the CPU is not being stressed at all, not generating hardly any heat. And with the tower air cooler I have on it, the fans really don't need to be spinning that fast. So in this video, I'm going to discuss installing fan control in Linux to give you better control over your fan speeds that's if your motherboard's BIOS isn't doing a good job at it. So now I've created basically instructions, which I'll pull them up here. I'm going to follow these instructions and show you as I implement these steps in the terminal. I'll also use a text editor. When I do use the text editor, if you feel more comfortable in the terminal text editor, for example, Nano or Vim or Emacs, feel free to use that text editor. But there's just certain things I'll be doing in the latter half of the video, which I think a GUI-based text editor just makes it a little easier. But initially, we'll start off in the terminal. I have instructions both for Debian-based distributions and Arch-based distributions. I've actually installed fan control in both systems. I've installed it in Linux Mint Debian Edition, which is the system I have here, although I've uninstalled it so I can show you the process. I've tried it out on Linux Mint Cinnamon 20.3. It works on that. I've done it in KDE Neon. It works well in that, and I've installed it in Arch Linux with the KDE desktop, and it works well in that. There's just some slight differences between the the Debian-based distributions and the Arch-based distributions. So initially, the first step is to install LM sensors and fan control. And the difference here, obviously, Debian's using the apt command, and Arch is using the pacman command, but LM sensors is named differently in the different for the Debian-based distributions, it's LM sensors. For the Arch-based distributions, it's LM sensors. So what I'll do here is I'll just copy and paste this into my terminal. And before you do this, go ahead and do an update for your package manager. So for example, in Debian, you would basically hit sudo apt update and before you do install the new packages, just make sure you get the latest packages. In Arch, go ahead before you use the Arch command, do sudo pacman-syu so that you can update before you install. Okay. Now this next command is detect the different sensors that the motherboard is offering. It'll detect the CPU sensors, and it'll also detect the GPU sensors. In my case, my GPU is a Gigabyte RX 580. It actually does a really good job at fan control on its own. So I don't use fan control for that video card. So if I see it asking me if I want to detect those sensors, I can say no. It doesn't, it really doesn't matter because I ignore them later on, even if it does detect them. So let's put that command into our terminal. First, let's clear the terminal so you see the command. Okay, so I'm going to hit sudo sensor detect. Now, before you do this, as a caveat, back up your system. And some research on certain motherboards, there may be some issues. I think it works perfectly fine on the majority of motherboards, but just to be sure, back up your system, for example, with time shift. I use time shift a lot. I actually do an automatic backup on all my systems every day with time shift. And that way, if something does get broken, you can just restore your system to its previous state. So with that, let's assume that I've already backed it up with time shift. I've actually created this test system on its own SSD for the purpose of this video. So we'll hit that. And basically, just hit Y or yes for everything that it asks. Now at this point, this is going to take a while. So at this point, I'm going to pause the video, and then when I'm done, I'll restart the video. Okay, I've completed the sensor to detect process. I've answered yes to all the questions. Now the next step is to enable the KMod service. In my experience on Arch, I did not need to run that command because it automatically started after reboot. But in the Debian-based distributions, I've had to actually manually enter this command into the terminal. Let's clear this again so you can see. So let's just paste that there. Okay, now we have to reboot, so I'm going to pause the video and I'll start again after I've rebooted. Okay, I've rebooted the computer, and now the next step is to type sudo PWM config. Okay, we're going to hit yes. Go through and hit yes. Hit return to continue. In my case, it asked, did I see or hear a fan stop during the above test? And I did, so I'll hit yes. Would you like to generate detailed correlation? Yes. Now, what this configuration is doing is it's testing the fans to find out what pulse width modulation settings correlate to which fan speeds, and also when the fan stops. And note that because we will come back to this, because later on in the configuration it'll ask us the speed at which the fan stops, and it'll give us an option to test it. But since it's really been tested already, we can come back to these settings and grab these settings here. Now that was just my first fan. I have 4 more fans to go. I'm going to again pause the video. I'll go through all of these steps for all of my fans, and then after I've completed this for all, you've already seen it go through one of the fans, so no sense in sitting through the rest. So I'll restart the video after the process. Okay, I have gone through the initial part of the PWM config, and I have 5 fans. I have a rear case fan, a fan for the CPU, and 3 front case fans. And you can see fan number 5, this is the point at which the fan stopped when the PWM setting was 28. For fan number 4 it was 26, for fan number 3 it was 28, for fan number 2 it was actually 12, and for fan number 1 it was 75. That's an older fan. I added my case only came with 3 fans. So now it is actually time to configure the fan outputs. Now as we look here, the hwmon 3, PWM 5, PWM 4, PWM 3, 2, and 1. These are my case fans. hwmon 3 is the module that Linux created when I rebooted last time. It assigned the directory name hwmon 3 for those fans. hwmon 1 is actually my GPU, which I'm not using fan control to control that. So we want to, in my case, I'm just going to configure these fans, the first 4 or 5 entries, but you'll notice they're actually out of order. It's 5, 4, 3, 2, 1, but I actually like to do it in the proper order just because it's easier for me to track. So I'm going to start configuring with fan number 1, which is my hwmon 3 / PWM 1, which is entry number 5. So I hit entry number 5. Now it's asking me, what do I want to use as a temperature sensor as a source for determining the speed at which the fan is rotating, basically. And it lists the devices up here. That's my graphics card. Really, the way I use the system, the CPU gets hotter than my GPU. Now, in any case, for your CPU fan, you're going to want to base it on core temp. Now, for your case fans, it depends on how you're using your computer. If you're using it for gaming and your graphics card gets really hot, you'll probably want to use you may want to use your GPU fan as your temperature source. But in my case, since I don't really game heavily on this computer and I mostly use it for other things that are CPU intensive, I'm going to base the fan speeds on the core temp, which is my CPU core temperature. And that is been assigned hwmon 2. So if I look at hwmon 2, that's these settings right here. These are the different core temperatures here. I have temp 1, temp 2, temp 3, temp 4, temp 5. Temps 1 and 3 are my highest. I suspect, I don't know for sure, that temp 1 is actually my CPU package temperature. But since it is one of the 2 highest readings, I'm going to base my fan speed on the temperature indicated by that sensor. And if I look down here, that sensor is sensor number 4. So what I'll do is enter here sensor number 4. Enter the low temperature below which the fan should spin at minimum speed. I actually, the default is 20. I usually just put 30 with modern CPUs. There's no sense for this fans to start ramping up at 20 degrees C, in my opinion, but you can take the default if you'd like. So I'll put 30 there. Enter the high temperature over which the fan should spin at maximum speed. Again, the goal of my system is quiet, and so I don't desire to have the speeds, the fans spinning at maximum speed when I'm at a 60-degree core temperature. These cores will automatically shut down when they get too hot anyways, which is usually above 100 degrees C. So I set this at 80 degrees. Again, you can take the default of 60 to be on the safe side. That's your choice. So I set that at enter the speed at which the PWM value, or enter the speed at which the fan stops, and that's the PWM value. Now for this was fan 1, so this particular fan stopped at 75, which I showed you earlier, so I put 75 here. You can test it again if you want to test it. Enter the PWM value at which the fan starts spinning. Now what I have noticed that on some of the fans this test just hangs. On some fans it doesn't. So you can push T to test your fan, it'll automatically detect that setting. What it does is it detects the speed at which the fan starts, the PWM setting at which the fan starts, and then it adds 20 to that value. Now I will test this fan just to see if it works this time. We'll hit test. So it's setting it to 75 because it knows that it stops at that value, and then it'll start ramping it up and detect when the fan starts. So we'll hopefully this works. I noticed with my CPU fan, even though when it went through the initial test and found that it stops at 12, it evidently, when it set it to 12, it didn't stop the second time. It's a Noctua fan, and so the fan speeds can go really slow. So this, I'm not sure if the fan has stopped yet. I'm looking right now. Yeah, the fan has stopped. That's my rear case fan. It is stopped now, so it should start testing it, slowly ramping it up to see when it starts. But it may be hanging again. If that's the case, what I'll do is I'll manually enter it. It did pass this test before, and it started around 130, and so the value it came up with was 150. So if this does not start here in a few seconds, I'll go ahead and pause the video, and we'll go ahead and manually enter 150 into that setting. Okay, I'm going to pause this recording, and we'll do a manual entry. Okay, that particular test didn't seem to be starting. Maybe it would have eventually, but I just stopped that test, and I again started re-entering the parameters. So in this case, I know that fan, a good value is 150, which is the default, so I'll take that value. Go here, so I'll just hit enter to take that value. Enter the PWM value to use when the temperature is below the temperature limit. 0 is default, I'll take that. Enter the PWM value to use when the temperature is over the high temperature limit. 255 is full speed. So basically, when my fan goes over 80 degrees Celsius, when my CPU temperature is over 80 degrees, the fan will go to maximum speed. So I'll take that default. So that is fan number, that's menu number 5, item 5, that's fan HWMON3 PWM1. Now I'll go ahead and pause the video again, and I'll complete the other 4 case fans. Okay, I've gone ahead and configured all 5 fans. Actually, it's 4 case fans and my CPU fan. The next item we'll address is number 7, which is change the interval. That's basically the time window that it's monitoring the temperature before it changes the fan speeds. With a longer interval, you'll have lower fluctuations in fan speeds, but your CPU temperature may get a little bit higher in temperature before it starts to respond. So lower interval, it will be more responsive, but if you get like a little peak surge in power, the fans may ramp up, even though you may not need it, especially if you have a tower cooler. So in this case, I'll select that, number 7, and then what I'll do is the default interval is 10 seconds. I'll change it to 5 seconds. And then let's show our configuration, which is menu item 10. So this shows the settings. This is a case fan, number 5, number 4, number 3, number 2 is my CPU fan, which actually does start at a lower speed, which I'm aware of, so I changed that to 100. And then this is my rear case fan. hwmon 1, PWM 1, that's actually for the GPU fan, which I'm not using fan control to control, so we'll ignore that for now. So now that we have verified that the configuration is correct, we'll hit 9 for save and quit. Now we're going to reboot the system. I'll pause the video. Actually, sorry about that. Before rebooting the system, we actually have to start the fan control service. So for Debian-based distros, we'll use this command. For Arch, we'll use both of these commands, system enable fan control.service and system control start fan control service. And then we'll reboot. The funny thing is, after the fan control service is started, the CPU fan does slow down, but the case, at least one of the case fans hasn't. Once we reboot, they should all be under fan control. So now I'll pause the video again. Okay, I rebooted the system. Also, I went to dinner too. But anyways, the system is now whisper quiet. But earlier I had mentioned that there's particular directories that sometimes get renamed, and this can create problems with fan control. And let me show you which directories those are and what is going on so you have an understanding, and then I'll show you how to fix it. So let's go to our file system. Let's open as root, because we'll have to be doing some root things in here. One note, I'm in the Nemo file manager in Linux Mint Cinnamon. Actually, this is a Linux Mint Debian edition with Cinnamon Desktop. And it has a context menu item to open a directory as root. KDE does have that ability, but not by default. Under KDE, you actually have to install the Open as Root plugin into the Dolphin File Manager. So if you do a quick search, you can figure out how to add plugins into Dolphin, and then you in the plugins search for Open as Root, install that plugin. You'll probably have to reboot, but once you do, you should also have this Open as Root capability. So we're going to open as root so that we can get in there and do what we need to do. Now be very careful, as I noted previously, make sure that you've backed your system up. I use time shift. That way, if anything goes wrong, you can just restore your system. Okay, let's look for the folders. Let me show you the folders where the information is changing. We'll go into System, then Devices, then Platform. Now, for the monitoring the core temperatures, everything is under this coretemp.0 file. And in here, there's a directory named hwmon, and here is another directory named hwmon2, and in here's the various sensor information that fan control accesses to monitor your system. The problem is that this hwmon2, that number, that digit right there, is dynamically created when Linux boots. And sometimes it will use number 2 on core temperature. I've seen it use number 3 sometimes. And then the same thing happens for the fan sensors. Now, if we go back to, let me open up another folder here. Let me go to my computer. Let me open file system. Let me open this as root also. Okay, let's close that out. Let's go into etc, and we're going to search for the fan control configuration file that we just generated when we did the PWM config operation. So this is the configuration file, and we'll be editing this to avoid the bug that we're talking about. Now in here it basically says hwmon2 equals core temp, so it's using hwmon2 for our core temperature data, and then it's using hwmon3 for this NCT 6775.656. It's actually this one right here. That is the controller on my motherboard. Your motherboard may have a different controller, but you'll know which file here to look at based on what this configuration file is showing. So in this case, this is my controller, and if we look at the controller, we go to hwmon, it is assigned hwmon3. Linux assigned that on boot, but the next time I boot it may be assigned hwmon4, in which case fan controller is not going to work. So what we are going to do is we're going to comment out these paths in this folder. This folder is under the etc directory. Once again, we went from our system into etc, and then we searched for fan control. And there it is right here. So we will comment out those paths. The problem is every time hwmon3 is called or hwmon2 is called, fan control won't know without those paths, it won't know where to go, and if those paths are wrong, it'll go to the wrong location. So we're going to set up static paths, but with a wildcard for that last digit, so that regardless of whether for the devices, for the core temp, whether it's hwmon2, hwmon3, hwmon4, fan control will find it, and the same thing for the controller. So let me move this over here, and I'm going to move some of this off screen. Okay, so I actually have the information that we have to replace in this in these directions here. So the first one we're going to replace is this core. We actually don't need to worry about temp 1 input. We're just going to replace this right here. We're going to replace everywhere where this configuration file is calling hwmon2. Again, that's because hwmon2 is the one that's going to core temp. Look at this first device path. Whatever hwmon is correlated with your core temp.0, that's the one we're replacing. So let's highlight that. We'll go search, replace hwmon2, and we're going to replace that with this. That's actually going to change these also in the device path and name. Well, you know what, we'll skip that. We'll go find next. Let's see. Next, next, next. And we'll replace that one, replace that one, replace that one, replace that one, and replace that one. Okay, so those are replaced. Now we have to do the exact same thing for hwmon3. So let's change this to hwmon3. But for hwmon3, let's bring this back down. Let's go back to our system, devices, platform, this folder is a folder that corresponds right here. So what we're going to do is we're going to replace down here core temp 0 with that folder name. Again, this is going to be motherboard dependent depending on which controller yours is using, but you can identify it from this line here. So it's just so we don't, we'll do the same thing. We'll search next, replace. We have a lot of replacing to do. Okay, now let's save that. So now our configuration file is going to, whatever Linux names those directories, it will find the core temperature information it needs and the PWM control information it needs to control the fans. But there's one more issue, and that issue is that there's an error checking, some error checking statements in the actual script code that fan control executes that's looking for these path statements. So and because we've commented them out, what fan control will do is exit with an error and it won't start. So we actually have to go modify that script code to comment out those certain lines that are doing the error checking. So let's do this. So we don't need this anymore. For there, we're going to go into, actually I have it listed in here that we have to change it. Okay, we're going to go into USR. Now for Debian-based distributions, this is what's happened for me in KDE Neon, Linux Mint, and in LMDE. We need to go into sbin, but in Arch, you actually need to go into bin to find the fan control file. Because this is a Debian-based distribution, we're going to look for it in sbin. And again, we'll just search for fan control, and here is the file. If we were in Arch, we would go into bin and we'd search for fan control, but because this is an Arch, it's not there. So let's go fan control. Let's open that up with the text editor. Okay. Now let's search for this. Basically, we have to comment out all these lines of code under that comment. So let's go here, search, find. There's the comments. So we need to comment it out. I believe it's like 15 lines of code there. So let's just put a little hash mark in front of each one of these. Okay, that's those files there that it indicates to comment out. So we've commented those out. So let's save that. Okay, so I'm going to close everything out, and if I didn't make any mistakes, we should still be whisper quiet, and fan control should continue working regardless of what Linux dynamically names those files. Okay, I've rebooted my system and it is whisper quiet, so fan control is still working. But this time it should continue working after a reboot. Now, you may not want to go ahead and jump into editing those files right away. See how your system responds. You may be lucky, and it may be that Linux just times after time assigns the same file name to those the same digit to those hwmon directories. And as long as it assigns that same digit that was used when you did your PWM config file, you're okay, and you don't need to go through that editing process. But on a couple different systems I've tried this on, that has changed, and so that's why I ended up figuring out how to edit those files to avoid that issue. There is one side note here. Let's go into our text editor. If we go in here and we type fan control, it's giving us an error that those files don't exist, but it doesn't seem to matter because it's still reading them and it's still operating properly. So there's evidently some other error checking that's going on, but that particular error doesn't seem to be interfering with the operation of the fan control. It is still controlling my fans. When I do something intensive and I start stressing the CPU, the fans ramp up in temperature. When I go back to just web browsing or document typing, it goes back to being quiet again. So just be aware of that. Again, it seems to be kind of one of those things that's a non-issue, but it's there. Anyways, I hope this has helped you. If you've learned anything in this video, or this has helped you, or if you just liked the video, please hit the like button. That'll help the YouTube algorithms direct other people who actually may need this to be able to find this content so that they can try to fix their fan control issues, because believe me, it takes some time to figure this stuff out, and if somebody can just come across this video, it will save them probably a lot of aggravation, because it took me a bit to figure out. I found some of the information online that was helpful, but I didn't find information that provided everything that I needed to do to get it fully functioning properly. Okay, that's it. Have a great day. Bye.